So we talked about matrices last week. Matrices, remember, are numbers in columns and rows. And so we're going to talk about how we can use just a straight up matrix rather than try to find a combination of determinants to solve a system of equations. So we are going to be looking for what we call a reduced augmented matrix. Remember, augmented matrix were the matrices that had the extra column that represented the solutions. So let me give you some examples of some reduced matrices. So let's say on the left it was 1, 0, 0, 1. And then we had 2 and 3 after the solutions bar. Okay, so we did this last week, but remember these are your x's, these are your y's, and this represents the equal sign. Okay, so the reason this is called a reduced matrix is because what is the first row telling you? It's telling you that x equals what? Like all that's left in the first row, you would say 1x plus 0y, right? So it's basically just telling you that x is 2. What is the second row telling you? Notice there's a 0 where the x is, right? So what's it actually giving you this time? The y is 3, okay? So the solution, if we can get a matrix to look like this, the solution is clear when it's in this format. When it's in this reduced format, and the solution would just be 2, 3. So let's look at another one that would be in reduced form. So same kind of thing, right? How would the first row read? X equals what? -1. And then the second row would read y equals 2. So the solution would just be -1, 2. Okay, so what do you notice about the left side of both of these matrices? It only has what 2 numbers, and then actually a very specific pattern at that. Only has 1s and 0s, right? And then a pretty specific pattern. It literally goes 1, 0, 0, 1. Okay. When you look at 3 variable matrices, this is what a reduced matrix would look like. And then maybe we can kind of generalize what the pattern looks like for any size matrix. So notice if you look at the left part of this matrix, it's still 1s and 0s, right? What do you notice about the 1s? They're kind of like in a downward diagonal, right? And then what's everywhere else other than where the 1s are? 0s everywhere else, right? So this first row would still read, by the way, because we have an extra column, these are your x's, these are your y's. What are these? Z's, and then you still have the equal sign. So for this one, we have that x is 2 from the first row. The second row has us read that y is -1, and then the third row has that z is 3. So the solution to this system would be 2, -1, 3. Okay, so in other words, this is what we're trying to get to. We want the left sides of any matrix we're trying to solve. We want the left side to look like the above examples. Because if it looks like them, then we should be able to determine what the solution is. But I don't think I probably have to tell you that all matrices aren't going to start off looking like this. If that's all it was, then you'd just be reading your answer and you'd be good to go. So the question is, how are we going to get all of our matrices to look like this? Okay, and the answer is we're going to do kind of a series of row operations. We never ever apply operations to the column, only to the row. So remember, the rows are the horizontal ones. So I'm going to talk about what we can do, and then we're going to talk about kind of why we're allowed to do them. So the first thing that you can do is you can swap any two rows. Okay? So let's just kind of look up here. Notice if you swapped this row and this row, it wouldn't read any different, right? It would just be that the second row would then tell you that x was 2, and the first row would tell you that y was -1. So it doesn't matter what order they're in. It's nice when they're in alphabetical order, but they don't have to be in alphabetical order, okay? So here is how you're going to know what to do. You're going to see something kind of like this. You're going to see R1, which stands for row 1, and then you're going to see a double-sided arrow, and then whatever row they want you to swap it with, they're going to list that second, okay? So this means that you're going to swap rows 1 and 2. Okay, so it's probably the easiest row operation we can have. You can swap any and all rows can be swapped so that you can get the pattern that you want. All right, so the second thing we can do to any row is we can multiply an entire row by any constant we want. Okay. So remember, these rows just stand for equations anyway, so all this says is that you're allowed to multiply any row by something as long as you do the same thing to the left as you do to the right, which we've known that rule for a long time. Okay. So here's an example of a command where it's asking you to do that. So if you see this, and I think it's pretty obvious what's going to need to happen, right? What do you think this command is telling us to do? So first of all, which row are we changing? What does this mean, R3? Row 3, right? What do you think it's asking you to multiply row 3 by? 1/2, right? So this means multiply all elements of row 3 by 1/2. Okay. If there was a 2 there, it would mean double all the things in row 3. Okay. And then if we changed up what row it was, it would just be referring to either row 1 or row 2 or something else. All right, so I'm going to put a star by this next row. It's maybe the hardest to explain, but it's also going to be one of the most often used row change operations. So you're also allowed to replace any row by adding a multiple of another row to it. So different textbooks and my lab shows it a specific way, but just know that if you learned this before in another class, it might have looked a little different because every textbook kind of has its own way of showing this. So if you see this, -2 R1 plus R2, okay, in this book, whatever's listed second is the row that's changing. And then this is telling you what to do to the row. So this means multiply row 1 by what? -2, okay? And add whatever you get there to row 2. So it's really not important if you use lowercase or uppercase letters, but I'm going to use uppercase letters so that it matches what label we have. Okay, and that's it. These are the only 3 things we can do to the rows, and we actually can't do anything at all to the columns. Okay, so I want to show you a couple row operations, and then I want to show you how we can use this to create a reduced matrix and get the solution to the system that we want. So you are going to need to do some basic arithmetic in your head. Arithmetic meaning maybe some multiplications, maybe some additions. You can get out a calculator if you must, but it's really better if you can take it easy and do them in your head as you go. So let's say you start off with this matrix. So first you just want to copy them down. Now remember, if I asked you to, you should be able to write what equations these stand for, right? Like this first row stands for 3x plus y plus 2z equals 0, and so on and so forth. All right, so let's say I ask you to take this matrix and I ask you to make this change. Okay, so how would you read that change? What am I asking you to do? Take everything in which row? Row 2, and what am I asking you to do with it? Multiply it by 2, right? So notice, what am I not asking you to change at all? Rows 1 and 3, right? So I'm going to copy those just as they are because no change is being requested on those rows. And then everything in row 2, I'm just going to double it. So this would be -2, 4, 6, and then 4 times 2 is 8. All right, so let's do one that's a little harder. I'm not probably even going to show you a row swap until we get to the actual example problems where we're using this, because a row swap is just really obvious and simple. So let's say this is the matrix that we begin with. And remember, these stand for equations, right? So this bottom equation would look like 2x plus 3y minus 6z equals 5. So let's say that I give you this instruction, negative r1 plus r2. By the way, you almost always see an arrow indicating that they want you to write the new matrix, like they want you to go ahead and make the changes that they mentioned. So which row is changing? The one listed second is the one that's changing. Okay, so row 2 is the only one changing. So what does that mean about rows 1 and 3 again? They're not changing, right? A lot of your homework and even some of the test questions is just going to be you being able to recognize when you're just copying numbers over, okay, when things aren't changing at all, but then also you being able to make the change. So how do you read this? How do you read this change I'm asking you to make? -3 times what? Row 1, and then I want you to add that to row 2, right? So this is what I mean by you have to be able to do basic arithmetic in your head. So we're just going to go slow. What is -3 times 1 plus 3? So it would be -3, right? -3 times 1 is -3, plus 3, so that's what? 0, right? -3 plus 3 is 0. And then let's do it again. -3 times this, so this is where you have to kind of visually pay attention. -3 times this plus this, right? What's -3 times 0? 0 plus 1 would be a 1. Okay, let's move on to this pair, right? -3 times this number plus that number, right? So what's -3 times 2? -6 plus a 2 would be a -4. And then last but not least, because you got to do it across the whole row, -3 times this number plus that number, okay? So -3 times 4 is -12, plus 5 would be -7. Okay. By the way, you might notice on this one that we kind of slowly started to get the pattern that we were looking for. Remember, what we're actually looking for in the end, which we're going to start practicing here in a little bit, is we want to see how we can get all the ones and zeros in place, okay, using only the row operations. All right, so let's do one more. Often you'll see a matrix with maybe 2 instructions. And to be honest, that's really just to save time / space. So let's write these out and then we're going to talk about what it means. So you might see 2r1 plus r2 but then also a second command of R1 plus R3. And these aren't considered together, they're just considered separate changes that we're going to make at the same time. So before we start, which row is changing here? Row 2 is changing because of the first set of instructions, right? What's changing because of the second instruction? Row 3, right? What is not changing then? What is just going to get carried over and have no change whatsoever? Row 1, right? So again, part of you getting these matrices right is sometimes just to figure out what needs to be carried over. And so it doesn't matter which one of these you do first. So I'm going to do this one first because I think it's easier. So what is this instruction telling you to do? Take everything in row 1 and do what? Add everything in row 3. So we're going to do like this plus this, right? And then this plus this, and then all the way down the line, right? So what is 1 plus negative 1? 0, and that goes here, right? 2 plus 4 is 6. Negative 3 plus 5 is 2. And 4 plus 8 is 12. Okay, so notice everything from row 1 got added to everything from row 3. Okay, this is a better lesson if you'll try to actually add them with me and subtract, or not add and subtract, but if you'll actually try to multiply and do all the math with me. So this one's a little tougher, but not too bad. So what is this telling you to do? Double everything in what row? Row 1, and add those to row 2, right? So we're just going to go slow, but 2 times 1 plus negative 2. So that'll be a 2 plus negative 2, which is a 0. Okay, let's go on to the next pair. 2 times this number plus that number, right? So 2 times 2 is 4, right? Plus 3 is what? 7. Move on to the next pair. 2 times negative 3 is what? Negative 6. Add 4 to that, and you get negative 2. And then lastly, 2 times 4 is 8, right? Plus the number under it. So 8 plus 6 is 14. Okay. So do you see how you can kind of take these at your own pace? And some of you might be able to fly through them a little quicker. And then some of you might have to stop and really think about, okay, what am I doing? Okay. I do think if you're a more visual person, it helps to like point the numbers out to yourself when you're doing it on your own. Okay. All right, so how are we going to get the matrix to look like we want? Okay, remember, so let's start with 2 variables. We want a 2-variable matrix to look like the following. Okay, we want it to look like 1, 0, 0, 1, and then we don't care what numbers show up here. So I'm just going to list them as A and B. Okay. And so, because if we can get them here, remember, we'll have our solution. So, to get here, to get to this point, we will use our row operations in some really specific ways. Okay, so you've been doing row operations in the past 3 examples with 3 variables, and we're going to take it back to 2. So I want you to write this step process down, and then if you can kind of plug in and remember this step and kind of just remember the order we're going in, then when we transition to a bigger matrix, like a 3 by 3, it's not so bad. So solving system of equations with 2 variables. Using matrices. So the first step is you start with column 1. Now I know I've been talking about row 1, so make sure you understand that I'm talking about column 1 now. Okay. So column 1, remember what you would like column 1 to look like. And here's your template for what you want it to look like, right? So column 1, you want to look like 1 followed by 0 under it. Okay, so step number 1 is I want you to get the 1 in place first. And you're going to do that by either row swapping it sometimes that works. So you want the 1 in place first by either doing a row swap occasionally, if it'll get you the 1 where you want it. But most likely it's going to be the second way. You can also multiply by the number's reciprocal. So you're going to multiply, remember, the entire row by the reciprocal. Okay, does anybody remember what reciprocal means? Like, what's the reciprocal of 1/2? 2 over 1, you just flip the fraction. Okay. So the reason why this works, by the way, is because 2 times 1/2, if it were 2, if you multiply by its reciprocal, it'll go to 1, which is what we're trying to get. We're trying to get a 1 where we want it. If you multiply, say, a 4/3 by its reciprocal of 3/4, you also get a 1. So anytime you multiply a number times its reciprocal, it always gives you 1. So that can be a really helpful tool to get a 1 where we want it. Okay, so once you get the 1 in place, you're going to get the 0 in place. And you're going to do that by adding a multiple of another row. And to do this, you're going to use the opposite sign. And I'm going to give you a couple of examples of that real briefly. So what I mean by that is if you have a 2 and you want that number to be a 0, what could you add to the 2 that would make it a 0? What could you add to 2 so that it would always be 0? -2, right? What if it were a -3? What could you add to the -3 so that, again, you would have a 0 where you want it to be? You could add 3. Okay, so -3 plus 3 would also give you 0. So notice that's going to let you get the 1 and the 0 where you want it. So then step number 2 is you're going to move on. Once you get that in place, you're going to move on to column 2. Okay, remember what you're going to want column 2 to look like. If you look up at our example of the reduced matrix, you actually want 0, 1 for column 2. Okay, and for step 2, you're going to repeat steps A and B. From step 1. So in other words, you're going to get the 1 in place first. And then the 0. And then notice this is for a 2 variable, right? So once you have your first and second columns done, you will write your solution as a point. So we're going to practice this a few times, okay? But how do you think you would transition to doing a 3 variable system? You would fix column 1, you would fix column 2, and then what would be an additional step we'd have to put in here because it's bigger? You'd have to fix column 3, okay? But the process is going to be very, very, very similar. The key is to fix the 1s first and then worry about getting the 0s in place. All right, so this is going to be really important, again, that you do this with me, not just that you copy down what I'm writing. You're really not going to get much out of, you know, copying my notes without actually actively participating. Because when you get to the point where you have to do these on your own, it's not going to help that you just kind of copied without thinking about it. All right, so let's say I told you to solve this as a matrix. By the way, what are we looking for in general if I asked you to solve this using a matrix? I'm looking for the points that they have in common, right? That's what I'm looking for, an x and a y. Okay, and I'm going to write my answer as a point. So the first thing I'm going to do is just write this as a matrix, right? So how could I write the first row? 2, -1, and then we put a bar, remember, and then 8, and then 1, 3, 11. Okay, remember, your goal is for the matrices to look like the reduced format, right? So what pattern am I looking to get? Which pattern would I prefer to have over here so that I would know the answer? I want 1, 0, 0, 1, right? That's what I want, okay? So keep that in mind. You always want to keep in mind what you want. So you just do this in a very methodical way. If you try to willy-nilly go at this in all different directions, then it's not going to work out because later steps will mess up previous steps, okay? But if you go in the order that I mentioned, it always works out, okay? So the first thing that you're going to try to do is you would like a 1 in this location, correct? Okay, so what would be a really actually quick way to get a 1 in that location? Couldn't we swap these rows? Like that was one of our row operations, right? So the first thing we're going to do is, and you have to say what you're going to do. So we're going to say we want to swap rows 1 and row 2. So just like it says, we're going to swap the locations of the rows. Notice we're not changing anything else. We're just swapping them out. Okay, so I like to put a little check mark here because notice that number is what we want it to be. Okay, so now we just get to work on the other numbers and get them to be what we want them to be. Okay, so if we go in a methodical order, what number needs to change next? Not the 3, right? We want to fix a column at a time, right? So the 2 is what needs to come next. Remember, we fix column 1, fix column 2, and then we're done, right? So what do we want this number to be? We want this to be a what? A 0. Okay? So how do you get zeros? You might need to look back at your steps. We get a 0 here by adding the opposite sign, right? So if we added a -2, for instance, we would have what we need. But we have to make sure we're doing one of the row operations. So we're going to do -2 times row 1, and we're going to add it to row 2. Okay? Remember, this is written correctly because this means that row 2 is changing. And row 2 is what I want to change, right? I want a 0 in that spot. So what is not changing then? And could just be pulled over. If row 2 is changing, row 1 isn't. So we're just going to pull over row 1. Okay, so let's do this operation, right? -2 times 1 plus 2, right? Because it's -2 times the first row plus the second row. So -2 plus 2 is 0, just like we wanted, right? That's what we were trying to get. Okay, and then let's continue on, right? -2 times 3 is -6, plus -1 is -7. -6 plus -1, right? And then -2 times this would be -22, plus 8 would be -14. So notice, now this is good, but so is that. Okay, so notice like every step we're getting closer and closer to the pattern we're looking for, right? So if column 1 is set, now we can move on to what? Column 2, okay? So we have 2 numbers to set, and remember, you always get the 1 first, always. Okay, so where should the 1 go? Where the 3 is or where the -7 is? Where the -7 is, right? So this is the number we want to work on next because we have to go in order so that we don't mess ourselves up. So I'd really like a 1 there, okay? So don't overcomplicate this. How could you make this a 1? We talked about it earlier. You can multiply by the what of that number? Reciprocal, right? What's the reciprocal of -7? -1/7, right? So I'm just going to do this -1/7 times row 2. But that's really just the same as dividing by -7. Okay? But which row is not changing at all? Row 2 is going to change, but which row is not going to change? Row 1. So we're just pulling that over. And then think to yourself, I'm really just dividing by -7, right? What's 0 divided by anything, actually? Still 0, right? -7 divided by itself is a 1, which is exactly what I wanted in that spot, right? What's -14 divided by -7? 2, positive 2, right? Because it's a negative divided by a negative. So notice, we're getting closer and closer. Now we're good to go in all 3 of those spots. So we only have 1 number left to change to what we want it to be, right? What's the 1 number that still isn't quite what we want it to be? The 3, right? What do we want this to be? 0. So remember, you get ones and zeros differently, right? You get a 1 by using the reciprocal. You get a 0 by adding the opposite sign, right? So what would you add to 3 that would make it a 0? Negative 3, right? So we're going to do negative 3 times the second row, because you can't just add a number. You have to do one of your row operations. And then we're going to add it to row 1. Okay? So remember, the second row listed is the one that's being changed. So notice row 2 is not changing in this step, right? Actually, if you think about it, row 2 is already complete. Row 2 is already exactly what we want it to be. Okay? So what is this telling us to do? Take everything in row 2 and multiply by negative 3, and then add what you get to row 1, right? So negative 3 times 0 plus 1, well, anything times 0 is still 0. Plus 1 would be 1. Negative 3 plus 3 would be 0, just like we want. And then negative 3 times 2 is negative 6, plus 11 would be 5. Okay? So now what do you notice about what we have now? It's perfectly reduced, and now what can you say based on the first row? Now you can say that x must have been what number? 5, and y must have been what number? 2, and so the solution that we get is 5, 2. Okay, so we're going to do another one, but I just want you to notice a couple of things. Notice that like once we set something to be what we wanted, it didn't get messed up. So if you find that earlier steps are getting screwed up by later steps, it means you're doing something wrong. If you're doing the things in the correct order that I just mentioned, fixing the ones in a column and then working on the zeros, your earlier steps will never ever get messed up. That's why I actually teach it this way. It's not the only way you can do this, but it's like the foolproof way that doesn't mess up previous steps. All right, so let's try another one and let's see if you can kind of get the hang of it a little bit better. Sometimes you might have to have fractions in some of these. So when you get numbers that you're not comfortable with, like fractions, or if the numbers are super big, remember that you can always use your calculator if you need to. Okay, so the first thing you're going to do is write these as a matrix. So 4, negative 1, and then the bar, and then 5, and then 3, 3, 0. Okay, so what do we want? We want 1, 0, and then a 1 here, and then a 0 here, right? In that specific order. Notice you kind of go in like a pinwheel order, right? So what do we want to start with? We want to start with 4, right? And we want to remember what we want 4 to be, right? What do we want 4 to be? We want 4 to be 1. Okay? So notice a row swap isn't really going to help us here, right? A row swap wouldn't get us the 1. It would just put a 3 in that spot, so that's not necessarily helpful. So I'm going to use the reciprocal, and I'm just going to say, okay, I want everything in row 1 to be divided by 4 or multiplied by a 4th. Okay? By the way, that means row 2 is not changing. So I'm just going to pull that over. I always pull over what's not changing first, and then I worry about what is changing. So what's 4 divided by 4? Because multiplying by a 4th just means dividing by 4. 1, right, just like we want. Negative 1 divided by 4 is negative 1/4. And then 5 divided by 4 is 5/4. Okay, so occasionally you might get fractions, and you're going to have to be temporarily okay with that. So notice, I've got the 1 just where I want. Okay, so which number should come next? Like, y'all tell me which location needs to come next. Yeah, this location needs to come next, right? And what do I want this to be? 0. I want this to be a 0. So I'm going to get it to be a 0 by adding what number? Negative 3, right? So I'm going to do negative 3 times row 1, and I'm going to add that to row 2. Because remember, whatever I list second, that's what's changing, right? So notice, which one's not changing then? Row 1's not changing, so we're going to pull that over first. Notice I don't even really give it too much thought. I just pull it over. So here's where you might want to have a calculator out, especially with these fraction ones, but I think you can get it without it. But if you need a calculator, you just use the math fraction key, okay? So let's do this one first, though. I don't think you need a calculator for this. Negative 3 times this plus this, right? So what's negative 3 plus 3, just like we wanted it to be? 0, okay? Then we're going to do negative 3 times this, right? Well, negative 3 times negative a fourth is just 3/4. And then plus 3 is going to actually be, if you use the math fraction key on your calculator, 15/4. If you did 3/4 plus 3, you'd get 15/4. And then here you're going to get negative 3 times this, so that's just going to be negative 15/4 plus 0, so that's going to stay negative 15/4. Okay, so I know we may not love the fractions, but they're actually usually going to go away if you just keep working your process. Okay, so what should come next? Which number should be tackled next? Yeah, this number right here comes next, right? Because it's where the what is. What do we want right here? 1. Okay, so don't overthink it, right? How do you get a 1? Always, just in general. You multiply by the what of the number? The reciprocal, right? So what's the reciprocal of 15/4? 4 over 15. So we're going to do 4 over 15 times the second row. So once again, which row is not being changed? Row 1. So I'll just pull that over. And then 0 times anything stays 0. This times its reciprocal is 1. Notice this is almost the reciprocal, but it's the negative version, so it's going to be negative 1. Okay, so notice, we're good here, we're good here, we're good here. So we're 3/4 of the way done, right? We've got 3 of the 4 numbers to be what we want. So what's the last number that needs to change? Yeah, this needs to be a what? A 0. Okay, so who cares that it's a fraction, right? How do you make a number a 0? We don't use the reciprocal to make a number a 0. What do we use instead? Yeah, we want the opposite sign, right? So we were going to add 1/4. So we're going to do a fourth times the second row plus the first row, because remember you list the number or the row that's changing in the second spot. So which row is not changing? Row 2. And actually, if you pay attention, row 2 is finished, right? Like row 2 already looks good. Like we already know what y is actually. So let's go through this process. So a fourth times 0, that's just 0, right? Plus 1 would still be 1. 1/4 plus a negative 1/4 is just what we wanted. It's 0. And then a fourth times negative 1 is negative a fourth, plus 5/4 would be 4/4 or 1. So we end up getting a pretty pleasant solution, even though we weren't sure we were going to get something like this, but we get x is 1 and y is negative 1. So the solution is just 1 comma negative 1. Okay. I didn't say this before, but remember, you can still check these. Okay, so you can still check by plugging in x and y. By the way, remember, this is just a fourth way to find solutions to systems, right? We already did addition/elimination. We did substitution. Last class, we looked at Kramer's rule, and so this is a fourth way for you to find the answer, and you can check them all on this test, okay? One of the reasons I think a lot of my students usually do better on test 3 than they did on the previous 2 tests, and I think a big reason for that is a lot of test 3 can be checked if you'll take a couple extra seconds to do so. So what I mean by checking it is you plug them back in here and make sure they work out, right? Make sure that 4 times your x minus your y actually gives you 5, and make sure that 3 times your x plus 3 times your y actually gives you 0. So I'm not going to show the check step because I think we've done it enough, but I just want to put a plug in there to make sure that you actually test it every once in a while. All right, so we are going to look at some 3 variables in just a minute. But let's look at our special cases. I don't know if you remember what our special cases are, but remember, you can get an answer of no solution, or you can get an answer of infinitely many solutions. So if you solve a matrix as far as you can, like you're going along and you're doing the process and you're pretty sure you did it right. Okay, so if you're solving it as far as you can go, but you get a row of all zeros, so if you get a row of all zeros and no clear solution, which does happen sometimes, So I'm not saying there's no solution, I'm saying there's no clear solution, okay? So when this happens, when you get all zeros, it means that the system has infinitely many answers. The reason you're not getting a clear answer is because there's an infinite number of them. So do you remember the word we used last week for that? Started with a D, dependent. So you're going to need to know both of these terms, but I'm pretty sure in this section, the multiple choice option will say dependent. So let me show you what an example of this is going to look like. So you're solving the matrix along, and you get it pretty close, but then you have to stop because this is what you get. So notice, you were able to get 1, 0 in the first column. How come you're never going to be able to make this a 1? This is where you'd go next, right? You'd want that to be a 1. What happens when you multiply 0 by anything, no matter what you try? It's going to stay what number? 0. It's going to stay 0, okay? So you're never going to be able to finish this out. You've got to stop there. So notice, this gives you two kind of sentences here. It tells you that x plus 2y is equal to 3. And it tells you that 0x plus 0y equals 0, which is already kind of a duh thing, right? 0 times something plus 0 times something else would always be 0, right? So in other words, this second row doesn't really give you any more information. So this would be a dependent system. And furthermore, it would be any point on the line x plus 2y equals 3. Okay, so I'm going to go ahead and circle this, and then I'm going to tell you how my lab likes to write this. Okay, so on my math lab, they use kind of the proper format. So on my lab, they're going to say it's dependent, and this is how they're going to write it. They're going to say all the points x, y that fall in the pattern x plus 2y equals 3. Okay, so all this means is all points on x plus 2y equals 3. It's just a really fancier way to say it. Okay, I'm okay with you saying this right here. I'm okay with using words to say any point on x plus 2y equals 3. But on my lab, it's going to give you something janky like this. And it might even have you enter in what the equation is. But it would be the same if you just use the words any point on blah, blah, blah. Okay, so that's the first special case. But the second special case is you get zeros on the left, but something else on the right. Okay, so you get zeros on the left, but you get something else on the right. Okay, and if that happens, then the system has no solution at all. Do you remember the term we used for that last week? It was inconsistent. In meaning not. So it's not consistent. In other words, there's not any answers whatsoever. So let's look at what that would look like. So if you had 3, 4, 0, 0, and then 6, 1. Notice it's not like the previous example, right? Notice that the second row has zeros on the left, but something else on the right. Okay, so notice the first row would be fine. 3x plus 4y equals 6. Okay, we have that. But the problem comes in the second row, right? This is not ever going to be true, right? Because 0 times something plus 0 times something should be what? Should be 0, right? And it's not. So we would say inconsistent. Or no solution. Okay? Because this right here is not possible. So I want to give you one of these, and then we're going to take a look at 3 variable systems. So we're not going to do one of each of these just for time reasons. So let's say I asked you to solve using a matrix. Two x minus 4y equals 6, and 4x minus 8y equals 12. So the first thing you're going to do is write it as a matrix. So 2, negative 4, 4, negative 8, and then after the bar is going to be 6 and 12. So you might notice something weird about this equation, that the second one looks like it's double of the first one. If you notice that, cool. If you don't, it's not really that big of a deal. So which number do you need to start with first? 2, right? What do you want right here? You want a 1. Okay, so how are you going to achieve that? What could you do to 2 that would give you a 1? Multiply by the reciprocal, right? So 1/2 times row 1. So notice row 2 doesn't need to change. I would say half of getting these matrix problems right is actually just copying down what's not changing at all, okay? And then half everything else. So this would be a 1, a negative 2, and a 3, okay? So we're good to go here. So we move on to which number next? 4, and we want this to be a what? 0. So we try to make that happen. So we're going to say, okay, negative 4 times the first row plus the second row should get us where we want to go. So first row is not changing. Second row, negative 4 plus 4 is 0. But then negative 4 times this is 8, plus this is also 0. So right here, you know it's either no solution or infinitely many solutions because of these zeros. What's going to make the difference as to what it is? What's right here, right? If it's a 0, which one is it? It's infinitely many solutions. If it's anything else, it's a no solution, okay? So notice if we do negative 4 times this plus this, negative 12 plus 12 is 0. So which one is it then? It's dependent. And I also want you to say more specifically, it would be any point on that first row. So how do you read the first row? X minus 2y equals 3. Okay, so the reason this ended up this way is because, again, this was all zeros. So notice, like, these are even quicker than the other ones, right? Because they actually fall apart after the second step. Okay, after the second step, you're going to notice, hey, something's janky with this, so it's going to be one of the special cases.